This lesson takes our knowledge of surface area to the next step, and we deal with another three-dimensional solid, which is called a sphere. Now, if you don't remember, a sphere is just a fancy word for a ball. Any ball is a sphere, and it still has a radius that goes from the center of the ball out to the edge of the circle, out to what we call the circumference of the circle. Now, if we examine this formula for surface area of a sphere, we see that there's parts of it that relate to a circle, like pi and the radius, and of course spheres have a connection. They are circular, so there should be some similarity between their formulas. Now we have three examples that we'll examine in this lesson, but in this lesson it's all working at a higher level of thought here, and we'll talk about what that means when we get into this first question dealing with the circumference of an NBA basketball. They're saying an official basketball has a circumference of 29.5 inches. How much leather, so basically how much surface area, is there on this basketball, which is a sphere? Now, the formula for spheres for the surface area has a radius in it. If I read this statement, nothing in there tells me what the radius is, but there is circumference of 29.5. Now, in earlier math lessons, in previous years of math, you would have learned that there is a formula to calculate the circumference of any round shape. The circumference is always 2 times pi times the radius. Now I need to use this in order to, at the end, be able to use our surface area formula. That is 4 times pi times the radius squared. I need to know my radius, but I don't have it yet. But what I do know is that the circumference is 29.5 inches. So I can replace that c for circumference with 29.5. And that equals 2 times pi times the radius. Now, as I just said, that 2 in pi is multiplying the radius. So to start to solve for the radius, I need to divide this out. I do the opposite operation. But whatever I do to one side, I need to continue to do on the other side. So the 2 pi's cancel out. And if I do this calculation, we're going to be able to find the radius of this basketball. Now I'm going to show you some things here that are important when we're using our calculator. Now it says 29.5 divided by 2 pi. What that means to you is you got to say 29.5 divided by, now we want this whole thing, this 2 pi, to be on the bottom. We want to say 29.5 divided by 2 pi as a whole. So my answer here, I'm using brackets, my answer is roughly 4.7 inches. Now I want to caution you on what a lot of people tend to do. They look at it and say, I need to go 29.5 divided by 2 pi. If you do this, your calculator actually will say 29.5. I'm going to divide that by 2. And I'm going to get an answer. Whatever that answer is, I'm going to multiply it by pi, which is not what we want to do. We want to divide by 2 and divide by pi. So you can see the difference now. If I forget those brackets, I have a huge difference, and my answer will be wrong. Another way to look at it, however, you could say I need to take 29.5 divided by 2, and I also want to divide by pi. So divide by both of them at the same, like divide and divide. Then you'd get your 4.7 again. But it's important that you know how to put it in your calculator. So now when we're looking at the surface area, if I have my radius, which we said is 4.7, and I square it, and there's the 4 pi, and that'll tell me my surface area. The surface area is 4 pi times 4.7 squared, which is 4 times pi times 4.7 times 4.7. So in our calculators, we could say 4 times pi times 4.7 squared, and this would give me a surface area in this basketball of 277.6, but the question does say to the nearest square inch, so that would round to approximately 278 square inches of leather in order to create that one NBA basketball. So we had to use our knowledge of circumference and some algebra skills to figure out our radius, and then eventually use it in the surface area question or a formula. This next question follows the same step. It's saying we have a circumference of a spherical gas tank to be 50 meters. What's the surface area of the tank? So how much metal is on the outside of that tank? So in the end, I'm going to want to use my surface area formula because it is a sphere, or it's a big giant steel ball. So I'm going to use 4 times pi times the radius squared. But again, if we read carefully, it says I have a circumference of 50 meters. I don't have a radius of 50 meters, so I'm going to use my circumference formula again, which is 2 pi r, and you can always ask for this formula if you forget it. And I'm going to find out my radius, because it does say my circumference is 50, and that is 2 pi r. And again, we want to isolate that r, get it by itself. So we're going to divide out this 2 pi, which will essentially cancel it out. But I'm going to divide it out of this side as well. So my radius, and I'll show on our calculator, again, how it should look. 50 divided by, and use brackets, 2 pi equals roughly 8. Or you could say 50 divided by 2 divided by pi. Still the same answer. So we're going to, for simplicity's sake, say, you know what, this storage tank has a radius of 8 meters, which is fairly large. Now I figured out my radius. I can go and put that in my surface area question or formula. So the surface area would be 4 times pi times the radius squared. So the surface area in my calculator, I'd say 4 times pi times the radius, which was 8 squared, equals, and we'll round to the nearest square meter, approximately 804 square meters of metal to make the spherical gas storage tank. So we have to realize that this is what I'm looking for in the end. If my question simply says the radius of this tank is whatever, we just jump right into our surface area formula. But we have to use our reading skills and say, is it telling me my radius, or is it telling me some information that can find the radius? Because here it said the circumference, so I had to use the circumference formula before I actually went into the surface area formula. So we'll switch now to the last question. We have this kid bouncing a ball, and it says this ball has a surface area of 9,900 square meters. And it's saying, or sorry, square centimeters. What is the radius of that ball? So it's asked me for the radius, and it gives me the surface area. So all I need to do is start with the surface area formula, 4 pi r squared. And I'm going to be using algebra to manipulate this to find the radius, because at the end of the day, it's saying what radius, what number for r is going to make this true. Now the question again, we're reading, it says surface area, 9,900 square centimeters. So this equals 9,900 square centimeters. And I have 4 pi r squared. Now I'm trying to isolate the r. So first off, just like the circumference formula, I could say, well, let's divide out this 4 pi. Let's get rid of it. So I divide it out of both sides. So it's gone there, which will leave me with a radius squared. And then in my calculator, I can, again, remembering the importance of those brackets, divide out the 4 pi. So 9,900 divided by 4 pi in brackets, or 9,900 divided by 4 divided by pi. And this will tell me that I have this answer, 787.8. Now, a lot of people will stop here and say, hey, this ball has a radius of 787, roughly, centimeters. Now, that's a ball that's almost 8 meters with a radius. That is a huge ball. There's something that we're missing here. And just like when we looked at Pythagoras, it's saying this radius is squared. So we need to know how to do the opposite of squaring something. And in order to do that, we just take the square root of our final answer. So the square root of 787.8 will tell me the radius. And it's the same step we do at the end of Pythagoras. So in your calculators, you're going to say, what's the square root of 787.8? And we'll round to the nearest centimeter. This child's play ball here is 28 centimeters for the radius. That makes a little bit more sense than what we know. So the ball has a 28 centimeter radius. So when we're doing these questions with surface area, the surface area of a sphere, the formula itself, which is surface area equals 4 pi r squared, It's an easy formula to work with if you're using a calculator. However, you have to take the time to read the question and say, is this question actually giving me my radius right off the bat? If it is, we jump right into this formula and we find our surface area. If it isn't giving us our radius, we have to use maybe the circumference formula to find it, or like in this last question of this child with the ball, we have to use the surface area formula to find the radius. You just have to read the question and actually ask, what information is it giving me, and what information is it asking me to find for a final answer?